Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing linked list topic and reversal pattern. Today we'll solve the second question, which is palindrome linked list. So let's read the problem statement. As you can see, we will be given a linked list and we have to check if the linked list is palindrome or not. Okay, means the first and the last node value should be same, not node, but its value should be same. Similarly, second and second last value should be same. Okay, so let's read the constraint. The constraint says it can, like, number of nodes can go from 1 to 10 power 5. Okay, 10 power 5 means if you are thinking to write the n square type of code, so 10 power 5 and 10 power 5 will become 10 power 10, and you know that 10 power 10 will definitely give us TLE. How I can say that? Because we have already discussed all these things in our time and space complexity video. If you have not watched, I'll add the link somewhere here. But as you know, in linked list we rarely solve O of n square time complexity. So in linked list we can go with linear solution but with optimized space complexity. So this is the linked list we have given and we have to check if this is palindrome or not. Okay, so forget about linked list. If we have array, how could we have solved it? Imagine we have 1, 2, 3, 2 and 1. Okay, by using two pointer approach. Can I say that? Why two pointer? Because left pointer and right pointer we have to check if first and last position elements are same or not. If they are same, next time we'll move this left pointer ahead and right pointer behind. Again we'll check if this 2 and 2 are same or not. Again, if yes, then we will move until the left and right become equal in the odd case, or left crosses right in the even case. What did I said? Suppose if we have only 4 length, so definitely right will be here. Now next time left will be here and right will be here, correct? As of now they are not same. Yes, in the next iteration left will come here and right will come here, correct? So that's what I said. In even case left will cross right, and in odd case left will become right first. So that's why until this condition becomes true, we keep on checking if array of left pointer and right pointer are same or not. If at any point of time they are not same, suppose this is 4 and this is 1, obviously they are not same. So it does not make sense to move ahead and check for other values, because we know 4 and 1 are not same. So anyhow this is not going to be palindrome. So we will return false then and there. But this is the linked list we have. So can I do one thing in the brute force approach? I will start iterating and read all the values 1, 2, 3 to 1, and I will put all the values in the list. Okay, and then I will apply this two pointer approach. So O of n time complexity to read the values from the linked list and insert in the list. Okay, and then another O of n by 2 time complexity to check if they are same or not. Why n by 2? Because left, right. In the next iteration left, right, and in the next iteration left and right. So you have just traveled, like, number of iterations are just O of n by 2, right? Because in the same iterations left and right both are moving ahead, correct? So O of n and O of n by 2, but still the space complexity will be O of n. Why? Because we have used extra space to store our values from linked list to list. Can we optimize it further? Yes, we can. But with what pattern? That we'll see. But first, let's see the brute force code. So this is the code we have discussed. We'll first create the array list and we'll move the head pointer one by one. We'll read all the values of the node and store in the list. Once done, we'll start two pointer, means I and j. I will start from 0th index and j will start from the end minus 1 index. Why end? End means length. So length minus 1 index. Until I is less than j. Why I said? Because if I is equal to j in the odd case, or if I greater than j in even case, we have to stop. So until this condition is true, keep checking if ith value and jth value are same. If they are not same, return false. If they are same, move left ahead and move right behind. And we have to keep doing this. If the while loop will run entirely without returning false, means the linked list was palindrome and we have to return true coming outside the while loop. And that's it. Let's run the code and let's try to submit this. So this code will get submitted definitely, where the time complexity is 3n by 2, space is O of n. So this is a brute force approach. How can we think for optimized approach? So in the linked list, if you remember, we have learned about basic operations, fast and slow pointer, yes, reversal pattern, yes, merge and sort pattern, yes. So basic operations, so we cannot apply because we have to check the palindrome. Basic operations means insert, delete and all those operations. We are not going to do this. Fast and slow pointer, we will apply when we have to count the mid, okay, or else when we have to check if there is cycle or not, okay. But in this case we need not to apply that. Reversal pattern, reversal means if we have to reverse it. Do you think we need to reverse here? Why I said? Because see, in this condition, suppose if it was not linked list, I just showed you that we can apply two pointer approach, means left pointer and right pointer, okay. Left pointer will move ahead, yes, but right pointer cannot come back. Why? Because this is linked list and the node is pointing ahead. What if the node was pointing behind? Means like this, then though we could have moved. Similarly, we will move next time left here and right if this node was reversed, okay. So don't you think it is just about reversing the half part? Yes, it is. So hence we can apply the reversal part, but not in the entire linked list, but half of the linked list. Now the question is how to keep track half of the linked list, and I just told you that we can apply fast and slow pointer when we have to calculate half or when we have to reach the half or middle of the linked list, correct? So in this case we have to reach middle of the linked list and then we have to reverse the second half of the linked list. Can I say that? Then the two pointer approach is valid, correct? Now how to calculate the mid of the linked list we have already discussed in our previous video. I'll add the link somewhere here, you can definitely check out. I'm not going to explain it again, but I'm assuming you already know how to calculate middle of the linked list. So this is where our mid will point, and now we have to reverse, correct? Now we have to reverse this. So forget about this. And also you know कि head pointer we cannot move, otherwise we'll lose the track of the left linked list, which we don't want. Okay, so head pointer is there, done. Mid we already have. This is what we have to reverse. So reversal technique we have learnt in our previous video, just previous video. So using that reversal technique we will reverse it, means this, this and this. So now the new head will become this. Can I say that? Okay, so let's say head 2 and this is head 1, done, middle point. So after reversal, this has been reversed in this direction and this has been reversed in this direction. Now what we will do, head 1 has 1, 2, 3 nodes and head 2 has only 1, 2 nodes. So definitely this is a smaller. So can I say in the odd case, head 1 will have greater length and head 2 will have smaller length linked list, and in the even case both will have equal. So can I say कि we will stop as per the head 2 condition, but with what? 1, 2. When we reversed, we would have connected this with the null, not 3. Remember that, because if you remember how to reverse, so in the reversal technique, the very first node from where we start to reverse, we connect this with the previous node and initially the previous node will be null. Can I say? So head 2, until the head 2 become null, we'll keep on iterating. Okay. So now what we will do, we'll start the condition कि while my head 2 does not become null. Now what we have to do, we have to check कि if our head 1 dot value not equals to head 2 dot value, then we can say this is not palindrome, so return false, done. Or else what we will do, we will just keep moving our head 1 ahead by head 1 dot next, similarly head 2 ahead by head 2 dot next, and that's it. Okay, so now we'll check 1, 1 same, yes. Next time what we'll do, we'll move this head 1 ahead and our head 2 also ahead. Again we'll check if they are the head 1 value and head 2 value are same, yes they are same. So again now what we will do, we'll move this head 1 ahead at 3, can I say? Yes. And now head 2 ahead at null, and as our head 2 is pointing to null, so this while loop will stop, correct? And after coming outside we have to return what? True. That's it. So can we write the code for this? So here is the code I have written for you all. First we have to initialize slow and fast pointer. Why? Because we have to reach the middle of the linked list so that second half we can revert. Okay, so until our fast become null or fast dot next become null, again these two conditions are for even or odd length linked list. Okay, and we'll keep on moving slow one time and for fast 2 times, so that we can reach the middle point. Once we'll come outside, wherever the slow is pointing to, that pointer will be our mid of the linked list. So once done, now our task is to reverse the linked list. So to reverse the linked list, we'll start our previous with the null pointer. Okay, and now again until the slow becomes null, we will reverse it. So these many lines of code are to reverse it. I hope you are aware of it. Once reversed, wherever is previous pointing to, means in this code, this previous is our new head. Okay, where I showed you, right, this head 2 which we showed earlier, this is nothing but your previous after reversing the code. So until the previous become null, which is head 2, keep checking if head dot value and previous dot value, if they are not same, return false then and there, or else move both with the same speed. After coming outside, if not false, means you can return true saying yes, this is palindrome. But what is the time complexity? See, O of n by 2 to calculate the mid. Why? Because fast is moving with double speed. So definitely this while loop is going to take O of n by 2, correct? So big O of n by 2 time complexity to calculate mid. Now similarly, can I say O of n by 2 to reverse? Why? Because this while loop code to reverse the linked list takes O of n only. But in this case, we are reversing the second half of the linked list. So that is why again this will also be n by 2. Okay. Now once done, again now this third while loop is to check if they are palindrome or not. So again this will also run for O of n by 2. Why? Because head previous. Now next time both will move ahead, head previous. Now next time both will move ahead, head and previous, and that's it. So for 5 length, only 3 times it moved, correct? So that's why. Okay. So this will also take O of n by 2 time complexity. Done. So in total O of n by 2, O of n by 2 and O of n by 2 means O of 3n by 2. But in this case, we have not taken any extra space. So this is space optimized code. Time complexity is 3n by 2. Earlier it was 2n, remember? And space complexity earlier it was O of n, but in this case it's constant. So that's why this is the most optimized code. Okay. Now let's try to submit this. Done, submitted, and as you can see it is a faster code also. So this was the code in Java. I hope you understood, and with a similar approach, here is the code in C++, whatever we discussed, calculate mid, reverse second half, and then check palindrome using the 2-pointer approach concept. Okay, and this is the Python code with the similar approach. So I hope you understood. If yes, then definitely you can go in the sheet and mark the second question also as done. And guys, if you are new to this channel, please do subscribe the channel, and if you have any doubt in this video or regarding from any videos, do let me know in the comment section, because we are following pattern wise DSA sheet. I hope you are learning a lot, and I hope you are understanding each and every concept which we are discussing in the video. But still, if you have any doubt, I will attach my social media links and the website link in the description. That's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.